Welcome to FEI TV. I'm your host, Dan Feinberg, and I'm joined today by JJ Blackwood, Senior Applications Engineer. JJ, you're here to talk to us about validating semiconductor samples for electron microscopes. Tell us about the problem that we're here to solve.
So in a semiconductor failure analysis lab, what you're trying to get is that great defect image that shows you the problem that's causing the yield loss in your fab. You want to get that image, be able to feed the data back to the fab and bump your yield up. Traditionally, preparing samples is a big investment in time and resources in order to get the sample prepared to the point where you can get that image. Usually that's done either by chemically or mechanically deprocessing the sample or polishing it in cross-section.
Ah, okay. So how do you know that the region of interest is actually in the sample?
As you're doing the deprocessing, either in cross-section or top-down, you go back and you do multiple inspections of your sample in an optical microscope. Now, as process geometries have gotten smaller and smaller, the defects, the corresponding defects that are causing all these problems have gotten smaller as well. So a lot of people are using their lab SEMs in order to do their validation of their sample prep.
Well, it sounds like that would get in the way of the productivity of the lab, wouldn't it?
Yeah, you're taking a tool that's already usually a bottleneck in your lab and throwing a bunch of additional work on it. And oftentimes your samples are dirty from the process of doing the sample preparation. So you have to go through, clean them, get them into the high-vac SEM, take your images. It just adds a lot of time to the process.
So I know our customers are really happy with the phenom being used for this. Can you show us a little bit about how that works?
So the basic idea here is that the phenom fits into your sample preparation flow. It allows you to get much higher quality data than an optical microscope in about the same time and about the same footprint. So here we've got an image of a bump, and you can get in here and see there's a void there.
Wow, that is cool.
It'd be really difficult to see that void optically, but we can do that in 30 seconds here on the phenom as part of our sample preparation process. And know that the sample, we've got a high confidence now, the sample's ready to get that final image. We can take it to our high-end SEM, or if we're, say, for example, making a TEM sample, we can take that to the TEM now and know we're going to get the data we need.
So how would you summarize the advantages of phenom over alternative methods for validating these samples?
The phenom's very fast. It's about 30 seconds to load, 30 seconds to unload, and it's going to give you much better data than an optical microscope. So it allows you to get that SEM data, that high confidence data, for about the same price and about the same footprint as your lab as an optical microscope.
Well, that's terrific. Thanks for joining us on FEI TV.